Hello, everyone. AWS live stream, and today we will be covering cloud computing. So let's start off by talking about what cloud computing actually is. The definition is the on-demand delivery of compute power, database storage, applications, and other IT resources to a cloud services platform via the internet with pay-as-you-go pricing. AWS had started cloud computing in 2006, where they sold IT infrastructure services to businesses as web services. And this essentially provided a simple way in order to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform, or AWS, owns and maintains the network connected hardware which is required for these services, while you both provision and use what you need. It helps build and run applications, and cloud can also be used for the deployment and management of applications. It's available to hundreds and thousands of customers across 190 countries. It gives powerful resources at low operational cost, and its classically provisioning services is like a Goldilocks problem. With AWS, you can elastically scale up and down as you may need. So let's talk about some cloud benefits. So some benefits are, the first one is the ability to deliver innovative new features to the market quicker. And you can focus on adding differentiated value, and this makes new ideas feasible, which were once out of reach. Here, experimentation becomes fast and low risk, and it can adjust to fit any workload. It helps businesses serve their customers globally without the need for expensive time-consuming expansion. And they can deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, etc. It also connects to personal infrastructure by private dedicated connectivity. Also, you can trade capital expense for variable expense. So this means that you only pay for what you consume and you only pay when consuming. You benefit from massive economies of scale, so there's a lower variable cost and you can achieve higher economies of scale, and this ultimately leads to lower prices. You can also stop guessing about capacity, so you can access as much or as little as needed, and you can scale up or down when necessary with a few minutes notice. You can also increase speed and agility, so you can reduce the time it takes to make resources available, and this causes a large increase in agility because the time and cost to experiment being extraordinarily lower. Also, you can stop spending money running and maintaining data centers, so you can focus on your own customers, and you can also go global in minutes. You can deploy your application in multiple regions around the world extremely quickly in just a few simple steps. And this ultimately means that you can provide lower latency and a better experience for your customers at a small cost. So let's talk about TCO, or total cost of ownership. Excuse me. Total cost of ownership reduces the need to invest in large capital decisions, and it provides a pay-as-you-go model which allows you to invest in the capacity that you both need and use. TCO calculators allow you to estimate the costs and savings. Calculators also modify assumptions that best meet your business needs. The calculator also provides directional guidance on possible savings. The tool is built on an underlying calculation model, and it generates a fair assessment of value that a customer may achieve. It's important to note here that the TCO calculator results are only used as an approximation. This is a video on cloud computing. It'll be posted in the description of the live stream once the live stream has ended, just like all of the other videos. Day 2 starts off by talking about the types of cloud computing. So there are several different models of cloud computing, and all of these allow for a different amount of control over web services. The three main types are infrastructure as a service, which is IaaS, platform as a service or PaaS, and software as a service or SaaS. So infrastructure as a service or IaaS. This contains the basic building blocks for cloud IT, and it typically provides access to networking features, computers, which is virtual or dedicated hardware, and data storage space. It has the highest level of flexibility and management, and it's most similar to existing IT resources. Also, it provides instant computing infrastructure. Platform as a service or PaaS. This removes the need for organizations to manage the underlying infrastructure, usually hardware and operating systems. allows for the focus of deployment and management of applications, helps business owners be more efficient, and it disregards the human concern over resource procurement, capacity planning, software maintenance, patching, etc. Also, it gives a combination of hardware and software components. Software as a service or SaaS. This provides customers with a completed product that's both ran and managed by the service provider. SaaS is usually referred to as end user applications, and there's no user concern about service maintenance or how infrastructure is managed. You only need to know how you're going to use the software. An example is a web based email to send and receive an email without having to manage feature additions. As versus PaaS versus SaaS. That's another video posted in the description. Day 3 starts off with talking about how to deploy cloud infrastructure easily. So there are 4 key main areas that you want to keep in mind in order to deploy the cloud infrastructure easily. Number 1 is a highly trusted global infrastructure. There's also providing a broad compatibility with all popular workloads, fast and secure private networking, and the tools to control access to all of the cloud resources. So highly trusted global infrastructure is designed for high security and availability needs of large enterprises. It offers capabilities that restrict unauthorized access or usage without sacrificing flexibility. It's a backup for all features. Number 2 is providing broad compatibility with all popular workloads. So this can spin up virtual servers, hard drives, databases, networks, and more. And it's easily set up virtual servers using either Linux or Windows. Fast and secure private networking provisions a private section of the AWS cloud that you define and retain control of. It's done with simple IP networking, and the cloud environment becomes an extension of your on-premises environment. It uses a standard pipe that encrypts data when it moves your environment to the cloud, and the more data creates dedicated network connection from your existing data centers to AWS. It also gives you a predictable network and a performance increase by bypassing the public internet. There are also tools to control access to all cloud resources, so you can create and manage users and integrate with your existing identity systems, and you're given greater flexibility in order to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of AWS. The cloud. So cloud-based applications are fully deployed in the cloud, and the applications in this cloud are created in the cloud, or they are migrated from an existing infrastructure in order to take advantage of benefits. Cloud-based applications can be built on low-level infrastructure, and they can also use higher services, which provide detachment from management, architecting, and scaling goals. Hybrid. So this is a way to connect infrastructure and applications. You connect cloud-based resources and existing resources. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting cloud resources to the internal system. And you run the applications in both the cloud and on-premise. You can also access AWS wherever necessary. On-premise is also referred to as the private cloud. This uses virtualization and resource management tools, and it's on-premises development, which leads to the inability to receive cloud computing benefits. It's used to provide dedicated resources, and typically it's the same as the previous IT infrastructure. Uses application management and virtualization technologies to attempt to increase the resource usage. And this is another video on cloud versus hybrid versus on-premise, which will be in the description. Day 4 starts off by talking about AWS security. So AWS infrastructure installs safeguards in order to protect privacy, and the data is kept in highly secure data centers. It manages dozens of compliance programs, and segments of compliance have already been completed. It has the high security without user managing their own facility. It saves money at the same time, and it also scales the security with your AWS cloud usage. It also maintains the security regardless of the cloud size. This is a video on AWS security, which once again will be in the description once this live stream has ended. AWS Analytics Services. So this is a set of services that handle every step of the analytics process. The services are powerful, flexible, and yet simple to use, and they enable organizations to put their unorganized data to work efficiently. Example services include the following: Elasticsearch, Amazon Kinesis, Amazon Redshift, and Amazon Athena. Elasticsearch is an open source search and analytics engine which is used to log analytics, real time application monitoring, and user click analytics. Amazon Kinesis enables you to absorb, buffer, and process streaming data in order to find insights promptly. Amazon Redshift can ask questions and combine exabytes of organized and disorganized data across your data warehouse, operational database, and data lake, which is a centralized repository that allows you to store all of your structured and unstructured data at any scale using a language called SQL or Standard Query Language. Amazon Athena is an interactive question service, which makes it simple to analyze data in Amazon Edge 3 by using SQL. AWS Compute Services offers multiple services that can deploy, run, and scale applications as virtual servers, containers, or code. Examples of this include the following. One of them is Amazon EC2, which obtains service quickly and inexpensively. Another one is Amazon Lightsail, which creates a virtual private server or VPS on AWS. Another one after that is Amazon Elastic Container Service or ECS, which runs in Docker containers, and that's software that is in standardized units, which is known as containers. The containers package everything the software needs to run, including libraries, system tools, code, and runtime. AWS Database Services. So these are necessary databases for applications such as managed relational, non-relational, data warehouse, in-memory data store, and graph databases. Amazon DynamoDB is a fast and flexible database service for any workload. You only pay for what you utilize, and the key value database that delivers nearly instantaneous single-digit performance at any scale is this one. It's built to handle internet applications, and it's a fully managed service. It also handles more than 1 trillion requests per day. Amazon Relational Database Service, or RDS, is a relational database service with 6 well-known database engines, and it can be set up, operated, and scaled in just a few steps. Finally, day 5 starts off by talking about AWS developer tools. So these contain codes that automatically create, evaluate, and deploy applications. They're a set of services that both quickly and carefully deliver software, and these services will store and hold control of your application source code. They're used for the constant integration, continuous delivery, infrastructure as a code, and monitoring. AWS Code Pipeline can create an end-to-end software release workflow using services. It's a continuous delivery service that automates the release of pipelines in order to have both a fast and reliable application as well as infrastructure updates. It also effectively and efficiently delivers features and updates. An AWS Cloud Development Kit, or AWS CDK, is an open software development structure, which is used to define your cloud application and resources using known programming languages. It supplies cloud applications, but it can be a challenging process that requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. CDK utilizes familiarity and expressive power of programming languages to modeling your applications. And finally, AWS Code Deploy is the tool which installs applications and updates servers. It lowers the workloads on developers and quickens the releases of new products and features, and makes it simple for users to rapidly release new features and help dodge the downtime during application deployment while dealing with the complexity of updating applications. Positives of this include automated deployments, minimized downtime, centralized control, and also being easy to adopt. Management tools allow you to provision, monitor, and set forth your cloud environment. You can maintain stable control without restricting your development speed. AWS CloudWatch is a service which was built for developers, system operators, site reliability engineers, or SRE, and IT managers. It provides information and insights that monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and also get an allied view of operational health. It gathers monitoring and operational data in the form of logs, metrics, and events, while providing you with a linked view of AWS resources, applications, and services that run on AWS and on-premise servers. AWS Cloud Formation provides a common language to supply important assets in the cloud, and provisions can be automated to be sent over and over again. It models infrastructure using a simple text file. And finally, AWS Systems Manager allows for the full control of the structure of AWS. It automates the tasks which are needed for smooth operations. It helps guarantee the security and compliance, and it detects problems quickly. Networking and content delivery services. These allow you to isolate your cloud infrastructure, scale your request handling capacity, and also connect your physical network to the private virtual network. The networking products would ultimately work together in order to meet requirements. Elastic Load Balancing coordinates with Amazon Virtual Private Cloud or VPC in order to give networking and security features. It distributes application traffic among different services, and it handles traffic in one or more availability zones or data centers. It also improves the scalability or adjustability of your applications. Storage services are a reliable, secure, and adjustable location for your data. AWS offers a wide variety of cloud storage services to support both the application and archival compliance requirements. Archival requirements are the dates when things can be archived or stored away and hard to get back. One can choose from different options to build the base of your cloud storage management solution, and in AWS, the different types of storage services include the following. They can include object storage, file storage, block storage, backup, data transfer, and also edge computing and storage. And this is a video on the introduction to AWS Web Services, and that's it for cloud computing. The next slideshow will be on innovation. Thank you for watching, and we hope to see you in the next stream.